Kia ora. Let's go over some enthalpy calculations. Now, firstly, how do scientists find out what the heat of reaction is? There are two different ways they can use. They can use what we call a coffee cup calorimeter or a bomb calorimeter. And you'll find more about how these work at level 3. What we just do at level 2 is use the information. So let's start. Here's one from the 2015 exam. Now, there's a lot of information, so you just skim and scan through there, and we'll just focus on the questions. Now, this one says, what term best describes this reaction, exothermic or endothermic? So to answer that question, you look at the heat of reaction and you look at the sign. What does it say? And it's a positive sign, so it must be endothermic, and that means that energy is absorbed. So it goes from the surroundings into the system. The next question. We, again, are given a lot of information. So if you skim and scan through, then just focus on the key values given. Now notice you get given a mass of carbon dioxide and a molar mass of carbon dioxide. So when you start off sorting out your problem, say that you're talking about carbon dioxide and list the mass and molar mass, and that should immediately make you think of the formula N is equal to small m over big M, because you get given mass, small m, molar mass, big M, so you can work out N. And if we put those values into this equation, then you'll get an amount of just under half a mole of carbon dioxide. Now, we have not finished yet, because when we go back here, we can see that 6 moles gives you this amount of energy. Now remember, although it says kilojoules per mole, it's relative to the equation. So we're looking at 6 moles gives you 2,803 kilojoules of energy. But we've only got less than half a mole. So you've got to do that conversion. And so if 6 moles gives that amount, then 1 mole will give 1/6 of that amount. So you take the 2,803 and divide by 6. And we want, though, for just under half a mole, so 0.45. So we multiply it by 0.45, and we get an answer of 210 kilojoules. Now, just a few points to remember. Always check your answer to see if it is sensible. If 6 moles gives you this amount, half a mole is less than 6, so your answer should be less than this amount. If you find your answer is bigger than that amount, you've made a mistake. Secondly, your values are given to 3 significant figures, so your answer should be given to 3 significant figures. Ideally, the 210 should be written actually as 2.10 times 10 to the 2 kilojoules. And that way you can clearly see the 3 significant figures. Right, let's do another problem. This is from the 2014 exam. And if you have a look here, again, it's a lot of information, so you just skim and scan through and highlight the key points. Firstly, you're given a whole lot of values. So I've highlighted in green what applies to methanol. So you get given the heat of reaction, you get given the molar mass, and you're also given a mass. And then I've highlighted in red what relates to ethanol. And you get given the molar mass as well as the mass. So as we know the mass and the molar mass, we can always work out the amount. So the way to start, divide your page into 2, work out methanol on one side, ethanol on the other side, and list your information. You can now work out the value by taking your mass and dividing it by your molar mass, and you get the amount in moles. So it's 10.78 moles. Now, if you look at the equation, you've got 2 moles gives you that. So 1 mole will give you half of 1,450. So to work it out, we just simply say 2 moles gives you 1,450, so 1 mole gives you half of that. So 10.78 is we just simply take this value and divide and multiply by 10.78, and this is our value, 7.816, or if we want to use it to 3 significant figures, it'll be 7.82 times 10 to the 3 kilojoules of energy is being released. So we can make it negative to show that energy is released. Let's look at the ethanol. So again, list your values, work it out, and you should see that you've got fewer moles because your molar mass is heavier. Now, look at the equation. If there's no number there, it's a 1. So 1 mole is 13, it releases 1370. So 7.5, you just multiply it by 7.5. And again, to 3 significant figures, you can round this off to 1.03 times 10 to the 4 kilojoules of energy. Sorry about that line. And that would then, you can see it's a bigger number than the 7.82 times 10 to the 3. So your final answer is that ethanol releases more energy than the methanol for the same mass. So make sure you answer that question. Right, for the final problem, we're now going to use where we go backwards, where you have to calculate the enthalpy. So again, there's a lot of information given. To skim and scan, highlight the important information. So we get given a mass of butane, the heat given off for butane. We get given an equation, and we also get given a molar mass. So the equation is over here, and remember the key one is we've got 2 molecules of butane, or 2 moles of butane, sorry. So let's do the same sort of thing. Take our substance and find out the values, the mass, the molar mass, so we can go straight to the amount. And just plug and chug into that formula, and you get given a very small amount of mole, 0.0629. So that releases 106 kilojoules of energy. That's what you are told. You need to find out the heat of reaction. Now, the heat of reaction for this equation is given is for 2 moles. Although the unit will be in kilojoules per mole, it'll be for this reaction 2 moles, because that's the way the equation is. So we first work out what it will be for 1 mole. So if 0.0629 gives this amount, then 1 mole you simply divide by that value, and you should come up with a bigger amount of energy being released, and then you double it for 2 moles, and you can see that our value is definitely bigger than the 106. Then finally, make sure you round off to 3 significant figures, and note your unit is kilojoules per mole. In the previous examples, it was kilojoule because we were just working out for a particular mass. Now we are working out the energy for a particular equation, so the unit is kilojoules per mole. All the best for your learning. Goodbye.